Okay guys, today we're going to be looking at section 4.3, perimeter and area. Okay, again, basic stuff that we're going with here. Perimeter, remember, is the distance around something. So it's the sums of the length of the sides. And area is the measure of the amount of surface that it covers. Okay. So I always think about perimeter as if I was going to put up a fence. Area, if I was going to wrap something in wrapping paper. Okay, and then volume, which we'll study later, is if I was going to fill something up with water. All right. Well, not surface area would be wrapping with wrapping paper. Area is if I was just going to, I don't know, make a blanket for it, I guess you could say. Okay, so perimeter, I'm iffy on ever giving perimeter of a rectangle this way, because I just usually say add these up, and just add them all up. But the technical perimeter is 2L plus 2W, 2 times the length times 2 times the width. But if you look here, my son just pulled up. That's why my dog's going nuts. She gets very excited. So you would have 6 feet here. You would have 4 feet here, so that's 10 and that's 10, so this would be 20 for the perimeter, 20 feet. Okay, the area, the bottom of this got cut off. The area of a rectangle is A equals length times width. Okay, so as we said, perimeter is 20 feet. Area deals in square units, so it's going to be 6 times 4 is 24 square feet. Okay, and that's how that works. Okay, next up, we're not going to be deriving the formulas. Excuse me. Area of a parallelogram. The area of a parallelogram with a height h and a base b is the area of h times b. Okay, so we have that formula. Then we have the formula of area of a triangle, which we all know is 1/2 base times height. I don't know why they put the h first. That really just, and they put the h first here. We always work in alphabetical order, but you know, whatever. All right, so find the area of the playground. This figure shows a recreation area in the shape of a parallelogram. If a pound of grass seed covers 100 square yards, how much green grass is needed to seed the entire area? Okay, and then B, suppose that we only want to see the triangular area. How much grass seed would be needed then? Okay. So let's do A first. We're doing the whole parallelogram, so we're doing base times height. Okay, so the base of this figure is 200 yards long. The height of this figure, remember height goes this way, it has to be a straight line, it's not this. Okay, this is not the height, straight up. So that's going to be 150. So that's going to be 30,000 square yards. That's the area. Now it says 1 pound of grass seed covers 100 square yards. So what we need to do is figure out how many pounds we need. So we take 30,000 and divide it by 100. So that means we need 300 pounds of grass seed. So let's say that the school goes, yeah, no, you're not getting that much money. We're not doing that. And okay, they're like, you're balling on a budget. So we go, okay, what if we only do this little area with grass? And they said, okay, cool. So let's figure out that one. So the area of a triangle is 1/2 base times height. Now, it tells me, you can't see it very well, maybe on your paper you can, that the base of this is 70 and the height is 150. So if you multiply that on your calculator really quickly, that's going to be 5,250 square yards. So let's see how many pounds of grass seed that's going to take. It's going to take 52.5 pounds. They're not going to sell you a 1/2 pound of grass seed. So you know you're going to have to buy 53 pounds of grass seed. All right, so let's look at this one. Find the area of the given triangle. So take a minute and do this one on your own, and then unmute it when you're finished. Okay, so we have area equals 1/2 base times height, because it's a triangle. So area equals 1/2 of 21 times 12. So when I type that into my calculator, I get 126 square units, because they did not give me a unit of measure. Remember, for area, you're going to put a square on whatever the unit is. If it's perimeter, you just leave it the plain unit. Okay? All right. Next page. Okay, finding the area of trapezoids in the, oops, I got that turned over to the wrong side. Sometimes we don't know the height of a triangle, but we do know the length of all 3 sides. In this case, we can use Heron's formula, and it's not our favorite, it's nobody's favorite, to find the area of the triangle. But if you only know the side lengths, then this is the way you have to do it. Suppose that the triangle has sides A, B, and C. We define the quantity S equals, so you have to do this first, add up all your sides and cut it in half. So take your perimeter, cut it in half, then plug that number in to this formula. Okay, now let's look at what we have here. Let's do a triangle first. It says, suppose you had 6 feet of stiff wire and could shape it into an equilateral triangle, a square, or a regular hexagon. Which figure would have the greatest area? Okay, so if you want to pause this and recreate this, okay, and then unpause it when you've got it drawn. Okay. All right. So we know that all 3 sides are 2 feet. So to find S, we're going to add up all 3 sides. Okay, so 2, 2, 2. So that's 1/2 of 6, and that's 3. All right, now we plug that in here. So we're going to do the square root of 3, open parentheses, 3 minus 2, times 3 minus 2, times 3 minus 2, because you do the S minus each of the sides. Okay, so let's do all of our subtractions. We get 1, 1, and 1. 3 times all those ones is just 3. So the square root of 3, if you type it into your calculator, is 1.73. So the area of the triangle would be 1.73 feet squared, and that means approximately. Now, we're not going to do Heron's formula for a square, because we can find the area of a square really quickly. It's unnecessary. So we're going to do 1.5 times 1.5. Okay? And the area is 2.25 square feet. So right now, the best figure to use is a square because you get more area out of it. All right, so now we look at this one. Now, because it's 6 feet and we're having to divide it up to a hexagon, each of these sides are going to be 1 foot. Okay? But we're looking at each triangle. Okay? We're just working with one triangle right now. So if you want to even shade it so you know that you're looking at, let's say, this triangle right here. All right. So we're going to do S equals 1/2 1 plus 1 plus 1. So 1/2 of 3 is 1.5. Okay, so that's our S. Now, there are 6 of these triangles, so we're going to take whatever we get for the area and multiply it by 6. Okay, area equals. So we're going to do 1.5 times 1.5 minus 1, 1.5. I'm not going to put this right here because it is all kinds of crammed up. I'm going to come down here to the bottom and do it. Sorry about that, folks. I have all this space and I'm not using it wisely. 6. This is 1.5 times 1.5 minus 1 times 1.5 minus 1 times 1.5 minus 1. So this is going to be 6. Then we have the square root of 1.5 times 0.5 times 0.5 times 0.5. And that's going to give me 6 times the square root of 0.1875. When I type that into my calculator, I'm going to get 2.60 square feet. So my greatest area is using the hexagon shape. Okay. Now, if we're looking at the area of a trapezoid, okay, the area of a trapezoid, you're going to add your 2 bases, so the base at the top, the base at the bottom, right here. Add these up, times it by this height, and then cut it in half. 1/2 base 1 plus base 2 times the height. Okay, so we go to the back side of this, finding the area of the trapezoid. So a sculptor has created a statue for the lobby of the town's historical society building. Sorry, I had a hole punch there. Because the building is old and the town engineer wants to reduce the weight of the platform the statue will rest on, he recommends that a hollow base instead of a solid one. The platform will be formed by joining 4 congruent trapezoids in one square as shown in the figure. To determine which materials will be best for the platform, the sculptor needs to know the surface area of the platform. Use the formulas we've developed so far to determine the surface area. So let's think about what we have here. Well, we have 1, 2, 3, 4 trapezoids on the side, and we have the square on top. So let's write that down. 4 trapezoids and 1 square. Okay, So for the trapezoid formula, our formula is 1/2 base 1 plus base 2 times the height. Okay, now if that's 4 feet and that's 4 feet, this is 4 feet as well. And this is 4 feet. Okay, so we can find this trapezoid and it's going to be the same all the way around. Okay, so we have 1/2 4 plus 6. The height they give me is 2. Okay, so 1/2 of 10 times 2. When I multiply all that together, I get 6. But remember, there are 4 of those. 4 times 6. Oh, wait, that's 20. Just kidding. I can't multiply. I was adding. 20. Half of 20 is 10. My apologies. So this is 40 square feet of trapezoids. Then we have 1 square. Okay, we can do length times width for the square. So the length and width of the square is 4 times 4, which is 16 square feet. Add those together, and the surface area is 56 square feet. Reviewing Pythagorean theorem. Remember the Pythagorean theorem measures right triangles. A and B are the legs. C is the hypotenuse. Okay, so you do a squared plus b squared equals c squared, and A and B really can interchange as to what's A and what's B. It really doesn't matter. Okay, all right, so let's do Pythagorean theorem right here. So the first one, remember our formula is a squared plus b squared equals c squared. So we do 8 squared plus 6 squared equals c squared. So this is 64 plus 36. That's 100. Okay. Then we're going to take the square root of 100 to get the c by itself. So c is 10 inches. All right. Then let's do this one. A squared plus b squared equals c squared. So this is 15 squared plus b squared equals 16 squared. So 15 squared is 225. 16 squared is 256. So we're going to subtract the 225. That's going to give me 31. When I take the square root of 31, B is approximately 5.57 meters. Okay, so we're just reviewing some basic math skills that we should know. Okay, so if you need to take a minute with that, feel free to do so. All right. All right, let's look at this pyramid. I'm not great at drawing pyramids, but here's my pyramid. This is a line drawing down from the top to the center, which is your height, and then the distance out to the middle and to this corner. So this creates a right triangle. Okay, and I've labeled that hypotenuse X. Okay, now it says the Great Pyramid near Cairo, Egypt is the tomb of the Egyptian pharaoh Khufu, also called Cheops by the Greeks. and was considered to be one of the 7 wonders of the ancient world. An archaeologist wants to determine the height of this pyramid. The pyramid has a square base measuring 230 meters on each side, and she has found the distance from one corner of the base to the tip of the pyramid, so this side right here, to be 219. What is the height of the pyramid? So if I draw this side splits in half to be 115 each. Okay? But I know that this side will also be 115. So I'm going to do Pythagorean theorem to find this x. And then once I have that, I will be able to do Pythagorean theorem here, okay, with hx, and this is your hypotenuse of 219. Okay, so I'm going to do 2 Pythagorean theorems. Okay, so let's do this one first. So we're going to do x squared. Well, let's do this. 115 squared plus 115 squared equals x squared. Well, 115 squared is 13,225. So that means that this is going to be 26,450. When I take the square root of that, and I really don't need to, because watch what I'm doing. I'm going to be doing x squared plus h squared equals the 219 squared. And so we can just put that x squared in there, if that makes sense. I don't know h squared. Okay, 219 squared is 47,961. So when I subtract the 26,450, h squared equals 21,511. Now I need to take the square root, so the height of this pyramid is 146.67 feet. Okay. Now, finishing up with circles, because that's what we finished up with in the last section. Circumference and area of a circle. Circumference is 2 pi r, and area is pi r squared. Okay? Now, a man is designing a basketball court for his children. The court is in the form of a segment of a circle. Okay, it's like a piece of pie, as shown in this figure. There will be a fence at the rounded end of the court, and he will paint the court with a concrete sealer. How much fence is required? So if I'm wanting it right here, what did we call this? This little piece right here? Arc length. So this is actually from last lesson. Okay, so they want arc length here. Okay, now, what's the area of the surface? So what they're going to want you to do, they're going to want you to find the area there. All right, so here we go. So remember, arc length is the central angle over 360 equals arc length over circumference. Okay, now the central angle, we said, if you look at this says it is right here it tells me 60 degrees. We don't know arc length. That's the part we want. Circumference is 2 times pi times the r. The r is 20. Tells you right there. So, cross multiply this. So 60 times 2 times pi times 20, which is 7539.82 equals 360x. So I divide by 360 and I get 20.94 feet. That is my arc length. That's how much fence I need. Now, it says to find area, but notice area here, we're not finding the area of a whole circle, we're finding the area of this. 60 out of 360 is 1/6, so that's why they're dividing the area by 6. Okay, so part B, they have pi r squared divided by 6. So that's pi times 20 squared divided by 6. So that's 400 pi divided by 6. When you type that into your calculator, you get 209.44 square feet. Okay? And that, my friends, is all. Oh, wait. We got to do this one over here. I almost lied to you. Okay, find the circumference of a circle, circumference and area. So circumference is 2 pi r. Okay, so we do 2 pi times 8. And that gives me 50.27 square units. And make sure you're using your pi button. Don't use 3.14. Okay, area is pi r squared. So this is pi times 8 squared, which is 201.06 square units. Now we're done. And if you have any questions, please reach out. Thanks. Have a great day.